A system of equations is two or more equations. You can have linear equations, you can have quadratic equations, you can have absolute value equations, but in this section, this part, we're just going to stick with linear equations. A solution is an XY ordered pair that satisfies the system. So it's an X and a Y that you can substitute in for each of the equations that you have. Now, example 1, solve by graphing. So this section is solving a systems by graphing. And what you're doing is you're trying to see where they intersect. So you're going to graph each line, see where they intersect, and that intersection point is going to be an ordered pair. So to graph this first equation, what I'm going to do is I'm going to solve for y and put it in slope-intercept form. So it's y equals 5 minus 2x. So my y-intercept is 5, and my slope is negative 2. So I'm going to go down 2, right 1, down 2, right 1, or up 2, left 1. In my second line, I'm going to graph using intercepts. So if I let y equal or x equals 0, then y is 2. So I'm going to put a dot at y is 2. And if I let y equals 0, x is negative 2. So I'll make a dot at negative 2. So these two lines, I'm going to finish this line. Sometimes I don't draw the line until after I have a lot of ordered pairs on there. These two lines intersect at this point, which is 1, 3. So 1, 3 is a solution. So to check my solution, I'm going to let this be x, this be y, and plug x and y into both equations, and they need to work. So if I do, is 2 times 1 plus 3 equal to 5? Yes, that works. Is the opposite of 1 plus 3 equal to 2? Yes, that works. Therefore, I know it's a solution to my system. So here's a table that goes through the vocab. So there's 3 different scenarios that you can have when you're graphing a system. You can have that they intersect once. So that is called one solution, and this is called an independent system. So these are intersecting lines. Coinciding means it's exact same line. So you're graphing the red line and you're graphing the blue line, and they're the same line. So there's no unique solution, it's dependent. This would also be called infinite solution. So it's exact same line. The lines are intersecting an infinite amount of times. Dependent, infinite solution, coinciding line, same line. In the last case is you could have 2 parallel lines. There's no solution, and it's inconsistent because it doesn't have a solution. These lines never intersect. So down here, so we're not going to actually graph them. We're going to write whether they have one solution, infinite solution, so the same line, or no solution. The same slope but different y-intercepts. So I can tell without graphing. Okay, so we're going to kind of manipulate these algebraically to see what I do is you can either solve for y in each one of these. Actually, let's do that. Let's just be consistent and do solve for y in each one. So if I solve for y in this one, I'm going to get y equals 5 minus 3x. If I solve for y in this one, I would subtract 15 and divide by 5. So it's going to be y equals 2/5 minus 3x. So right here you have the same slope but you have different y-intercepts. So same slope, different y-intercepts would be this situation. You have the same slope, so they're parallel, but you have a different y-intercept. So this would be an inconsistent system. This one's inconsistent. And the second one, I'm going to solve for y. I already have the first equation solved. So I'm going to solve for y by adding 4x and dividing both sides by 2. So I'm going to get the second one's equation for it's going to be 3 plus 2x. So if I look at both of these, I have a y-intercept of 3 and a y-intercept of 3, a slope of 2 and a slope of 2. So this has to be the exact same line. If I rewrite the top one down here, it's going to be 3 plus 2x, exact same line. So we know that if it's the same line, they're coinciding lines. There's no unique solution. There's no unique solution because there's an infinite number of solutions. It's a dependent system. And then the last one, I'm going to solve for y. So I'm going to get negative y equals 5 minus x. Y equals negative 5 plus x. That's the first equation. The second equation is going to be y equals 2x minus 3. So what we have here is we have different slopes. So automatically if their slopes are different, it's going to be independent and there's going to be one solution. So make sure you know the differences among these three, so know which ones are dependent, inconsistent, or independent.